Well, it seemed like I've seen a few videos where the inverter generators came up on YouTube, suggested, and a really good one that got me going was Jason Wallace's video where he's comparing the waveforms. Really, this is like one of my favorite videos, comparing the generators, new favorites I should say, I try not to have favorites, but excellent video, comparing the waveform of mains 120 voltage VAC output, the inverter generator output, which is pure sine wave, and then the conventional synchronous, your typical generator output waveform. And this could be AVR controlled, auto voltage regulator, or not. So the older versions, before they had the AVRs installed, so I don't understand exactly, but I guess it was just a fixed rotor power, so that rotor magnet, electromagnet would be charged. And you can get into asynchronous generators, which is basically a permanent magnet. Rotor typically, but they can be a stator, I guess, with these newer inverters. And then the magnets are fixed. So, kind of back to where I was, that thought got me looking at these inverter converters, how they run. I never saw how the generator, the actual alternator part works. It's actually what I consider an alternator, an AC outputting generator. I guess some say the dynamos, that the true DC output, but I usually think of the generator as DC and the alternator as AC. Well, it's a multi-phase design, axial type discs, kind of like the newer washing machines are. And basically what you're doing is you're taking the asynchronous, which is also known as a brushless generator, motor, alternator, and you're rectifying it to DC. Then with the DC output, you're inverting to create that pure sine wave. And I probably should have pulled up another video to show. Maybe I'll do that. I'll pause, but I'll do that a little later when I get to waveforms again. But yeah, so old John Daniel, he had a good video. I think he just put recent out with the inverter generator showing the weld. So it's like, well, I'm going to go ahead and detail what my thoughts are. And this is going back to, this is a Gen 2. Weber Auto, excellent. Gentleman here does an excellent job tearing down in general. The school must be great, for probably one of the best for hybrids. Though, there's an awesome demonstrator. The school down here, the gentleman has how the Prius hybrid drivetrain works. In regards to that, I don't want to go off on scope creep too much, but in general, for how the Prius hybrid drivetrain works, he's got the best generator, and that's super inspiring, because I want to do that. I kind of want to get a Gen 2. I see them, and the engines are cheaper. That's what leads me to kind of work on Gen 2. But I own a Gen 3 Prius, so I wound up getting 3 of the inverter converters. And Damian McGuire, he does a great job tearing down the and assessing the Prius Gen 3 inverter converter. In fact, right there, he's pointing to the IGBT control board, and the IGBT's in here. You go back to this video, the gentleman's pointing out that IGBT module and noting you want to be very careful cooling those. My thought was, is least amount of impact to modify, maybe not even pulling out the IGBTs, but it seems like it's probably going to be easier to pull those out and create your own microcontroller unit IGBT board to do what I want to do ultimately, is not just make a generator, inverter generator. Looks like I kind of want to go through originally analog designs just to study. I probably still am and will more. Maybe hands-on, but I have this feeling I'm just going to jump right into the inverter design. And then making not only the power output device, which might be I'll even do 460, 480, with these 3-phase motor 1, motor 2, motor generator 1 and 2 CVTs from the Prius Gen 3 that I own already. I own 3, like I said, 3 of those inverter converters. I was like, no way, I can't believe the price. It's amazing. So I had to buy them when I had the chance. But my mind at least. I want to do a welder and plasma cutter while I'm at it. So basically, real quick, if you're not familiar with what I explained prior, say like in a little more detail, just noting with the asynchronous or brushless motors, which is what the Prius MG1 and MG2 are, you have this super simple H-bridge design. Physics, I forget what her last name is, Eugenie, something, Slavic language sounding, sounds probably more like Ukrainian or Russian. You basically have these 4 IGBTs, and we'll go with IGBTs just to explain the H-bridge better. It looks like an H. And what you're doing is you're switching back and forth. Maybe I'll just go ahead and play. And you see you switch. So you got your DC source, and here's your AC output.
An inductor tries to keep the current flowing through it constant.
And it's kind of paused, but there you go. It switches now. So you have this going at 60 cycles a second, then you're at 60 hertz frequency. So you can control the frequency. And what you got going there is basically a VFD, a variable frequency drive. And this is a better overview for three-phase systems. So what you'd have coming out of, say, the MG1, MG2, or both, you'd rectify. And you can get three-phase rectifiers cost-effectively online nowadays. And then you'd have, this is kind of black box looking, but these would be your IGBTs, which would be in your inverter of the Prius Inverter-Converter box, module, assembly. And what you're going to do is you're going to control those with like basically a microcontroller unit. You could probably use a solid state. I mean, you could probably figure out a two-way, basically a hardware only system without using firmware, or without even, I guess you could even use SBC, a small board computer, like something, I don't know, a Pi or something. But an Arduino, STM, a Teensy, PIX, a microcontroller unit will control the switching of these IGBTs based on what the IGBT specifications are for that gate control. So, which a gate's like a switch, basically, to switch what's going on. And so you have, basically, at those higher frequencies, you see your inputs coming in, sine wave, or it could be crummy sine wave, asynchronous source. Your full bridge rectifying here, so you're getting the positive and the negative parts coming up positive. Then you're making that smooth out with capacitors and inductors, and then you're sending it into the IGBTs. So you're switching a duty cycle. It's really, slowly, really fast. Like not just a complete frequency cycle at 60 hertz. You're actually doing a pulse train control of some sort with, very short time and controlled amplitude. So you're slowly, just really quick, recreating as smooth of waveform as you can for that cycle you want. And so while you're at it with the microcontroller unit, which is what I plan to do, is so you basically can recreate for a welder. Maybe if you needed to change, you can also change your voltage, and basically your output power. But I want to change the waveforms for welding. And originally it was for duty cycle changing, so you'd have more positive, more negative. So for this is what you'd want, so you don't have to worry about high frequency controls when welding. I don't really know welding in detail with using the triangle, or there's a sawtooth straight up, down type wave, and the soft square. So these are interesting. As a welder, welders will know that. I might learn that later. But for output for a generator, this is what you want, single phase. So, also, what taught me how the inverters work was just studying a cheap, this isn't the best video, there's a better video, but there's a couple of videos on converting a modified, technically it's a modified sine wave, they call a square wave inverter, into a sine wave inverter. You can see it's kind of a modified sine wave, but I like how they say it's a square wave. that I didn't realize how bad those look. But you basically, with the sine wave inverting, the H-bridge, you smooth that out so it's a better looking signal, you know, than the input signals from the mains or from those synchronous motors. So, I don't know, I just wanted to show these videos real quick, get them all documented. This is something I've had on my mind. Slowly and mostly I've acquired everything. I think the only thing I don't have, which I have to look in the Inverter-Converter because I kind of slowed down getting those. If I don't need to get them, I don't need them. But is the rectifiers. There must be a rectifier on here to, maybe there isn't high enough, to take the asynchronous drive, the motor generator, well, asynchronous brushless motor signal that's going to be very erratic, change that to DC. So somewhere there must be a rectifier going on before that goes into the battery. So I didn't order, but if you want to, you can order the 3-phase rectifiers that should be able to handle the voltage and current online for $20, $30. So, you know, basically you can take even your crummy generator, and the asynchronous isn't even shown. The waveform for the asynchronous is even more erratic. And this is just showing...
or sine wave from the inverter generator.
Yeah, this is just showing images. It's not showing changes with and without load and different loads. Because asynchronous, depending on your load, the resistance of that circuit, oh man, it can make that voltage really go up and down and be really bad. So, this is another video. This isn't the one either, but this one is a really good video, I think, for detailing the modified to square wave inverter to pure sine wave. Paradigm of thinking for the controlling, with feedbacks in particular. This is a section where he's talking about the feedback, and you'll see a big difference in the quality of the signal, because that's another aspect of the design that's not really shown in here. This is a super basic. It might be they are that basic for a variable frequency drive, but when you want more controls to be able to select different voltages, frequencies, balancing, you know, more, well, I guess you'd really be DC electrode positive versus DC electrode negative. You have to have a lot more logic involved, algorithms and controls. So I think that's about it. These are the videos I wanted to show. I thought were good videos that inspired me over the years. To the latest, reminding me to make this video, so I guess I get it documented, to show, and really more so the last few days, this video, because I'm like, man, just having that inverter alone for the synchronous generators, the older ones, whether or not the auto voltage regulator, that would really make these improve better, and it seems like that can be done cost effectively, and kind of makes me think a little more about modularizing that control. So you say you could plug it into, you know, your generator. I mean, probably could just make it so the module plugs into your mains outlet. And you can, you know, use it as a cleaner output source and a welder, plasma cutter, you know, modify that output depending on what the input is. Potentially also having different voltages, not just, you know, for the welding more so. The frequency, I suppose, maybe as a power supply, if you had avionic aircraft type systems, the thing is, well, no, with changing the voltage, you should be able to theoretically, if I'm understanding everything correctly, have those, I think it's like 400 hertz those operate at. They're a higher frequency, not a 60 hertz design AC, so that you can run those devices also. If maybe you have, you know, you're testing them or you have some sort of need to, or maybe you're designing them, I don't know. But anyways, I'm getting 15 minutes. I usually don't make this long videos, but I want to document the thoughts on my mind, get them out there. I got a lot of stuff I've got the parts for. I just haven't moved forward with actually designing, having the plan locked down. whatever, if I need custom, you know, CAD works or CAD, you know, work done, you know, draw up what I need to make sure whatever I'm doing safely, not just laying stuff out and working on. So I've got my jigs or fixtures, you know, to work with, and also plans down. So I've got schematics drawn so I can review those with others to make sure I'm not off in, you know, some kind of crazy train of thought, you know, some funky whatever signal path. And it's not my own, I think. It might be my own too. I'm not perfect. But, and definitely not expert at this stuff. So, but I'm learning like anybody wants to, you can. So you should be able to. It takes time. And this has taken years to learn all this. So it's not full-time learning either. So, you know, it takes time. So, but get all the proper prior planning, prevent piss poor performance done. So I got all my documentation, you know, my design down. So I got my design specifications, you know, before I start installing anything, definitely before I start operating and doing performance tests with. So, okay, I hope you all have a good one out there. Be safe, stay healthy, learn something new, and keep Christ with you, and follow through. So just keep moving forward, man. Hold your ground, and, you know, follow through and move it forward when you can. All right, talk to you later. Bye for now.